Hi children, I hope you are all well and enjoying learning and studying mathematics. In today's lesson, we will develop a method to find the factors of a prime or a composite number. In our previous lesson, you learned the meaning of prime factorization and the importance of it. Now let's continue with the new subject. This new subject is the factors, to find the factors of a prime or a composite number. By factor I mean a positive integer. A factor of a number is an integer which divides this number. In this case, when we say factors of a number, we should think of numbers that divide this number. So, a factor means divisor. Okay, factor is equal to divisor in a different manner. So now let's start with a small and a simple example to understand better. Choose a number 6, for example. I will try to find all positive divisors of 6 by divisor or factor. I mean, numbers divide, positive integers divide 6. Okay. You know multiplication very well. So you may write, if you write 6 as the multiplication of the numbers, you may reach these divisors or factors. For example, 6 may be written as 1 times 6. So 1 and 6 are factors of 6 because 6 is divisible by 1 and itself. Is there any other multiplication for 6 with different numbers or other than 1 and 6? Yes, 6 is also equal to 2 times 3. It means 2 and 3 are factors of 6 again. Can you find another for 6? No. So let's write all factors of 6 from smallest to greatest. The first one is 1. The second is 2, then 3 and 6. These numbers are the factors of 6, as you see. Now I used here multiplication to find the factors of 6. It was very easy because 6 is very small number and easy to find all factors of 6. Let's continue with another number. 24 is equal to 1 times 24. And let's continue with another one. Can you find other two numbers? Their multiplication is 24. Yes, 2 times 12. Is there another? Yes. 3 times 8. 3 times 8 is also equal to 24. And is there another? Yes, 4 times 6. Now, I wrote here multiplication of two numbers. In the first number was 1 and the second is 24. Their multiplication is 24. Then the first factor or first number, as you see, increased 1, 2, 3, and 4. And when the first number increases, then the second number decreases, of course, to find 24. Now, after 4, 5 is not possible. 5. Because 24 is not divisible by 5. After 5, 6 comes. 6 is possible, but I wrote here. So, my operation has just finished. I cannot find any two numbers whose multiplication is equal to 24 other than this. So, let's write all factors or divisors of 24 starting from the smallest one. The first one is 1. Now for all numbers, when I find their factors, as you see, 1 is always the factor. So 1, after that 2, after that 3, after that 4, and then 6, then 8, and then 12, and then 24. That's all. Yes, for these two examples, the numbers 6 and 24 were very small numbers. Because of this fact, I easily found their factors by multiplication method. This is so multiplication is the method to find the factors of a number. Is there any other? Let's check it. Let's try to work on the factors of 24. 1, 2, 3, 4. After that 6. After that 8, 12, and 24. Now, you know 4 times 6 gives you 24. So, after 4, I don't need to write, pay attention on this point. After 4 comes 6. If you know 4, then because of being 4 times 6 is 24, you will reach 6. If you know 4 as the factor of the 24, you may reach 6 because 4 times 6 is 24. If you know 3, you will reach 8. If you know 2, you will reach 12. If you know 1, you will reach 24. So after 4, there is no actual number who gives you, well, multiplication 24. After 4, writing 6 is not a new invention. So divide these all numbers from here. Separate them from each other. And let's clean 6, 8, 12, and 24. I will reach them again by multiplying method. 24 is divisible by 1, by 2, by 3, by 4. After that, 4 times 6 is 24, so write 6 here. 3 times 8 is 24, so write here 8. 2 times 12 is 24, so write here 12. Sorry, 1 times 24, so write here 24. Did you see the result? We reached all other factors after 4, the remaining factors of the 24, by multiplication. But why I stop here at 4? Why I stop? Why? I should stop somewhere. So 24 is divisible by 1, 24 is divisible by 2, 24 is divisible by 3, 24 is divisible by 4, and I should concentrate on, I should pay attention after 4. Because after 4 comes 5. What is 5 square? 5 square is 25. And 25 is greater than 24. That's why I should stop at 4. 4 square is 16. 16 is less than 24. 3 square is 9, less than 24. 2 square, 1 square, all results are less than 24. But after 4, 5 comes, and 5 square exceeds 24. So, did you understand where I should stop? Yes, at 4 I should stop. Whose square at the end is less than the given number, 24. But after 4, 5 comes, 5 square is firstly becoming greater than the given number, 24. So, please write all numbers whose squares are less than 24 or the given number. For 24, 1, 2, 3, and 4 are possible. But after 4, 5, 5 square is firstly exceeds 24, so don't write 5. So here, after 4. 4 times, ask to yourself, 4 times which number gives you 24? 6. 3 times which number gives you 24? 8. 2 times which number gives you 24? 12. 1 times which number gives you 24? 24, sorry. So this operation exactly, certainly will give you all positive numbers or all factors of 24. This is the method coming from multiplication or product method. Okay, now let's apply on the next page another example, this method. Let's choose a huge number, 360. This is 360 is our famous number. Now start from 1. 1 is possible, 2 is possible. I am writing all divisors starting from 1 and continue like this. After 1, 2 comes, is 2 divisor of 360? Yes. What about 3? 3 is also possible. It's divisible by 3. And 4. 4 is possible because the last 2 digits makes 60, and 60 is divisible by 4. What about 5? 5 is also okay. What about 6? 36 is divisible by 6. That's okay. I should write here. But at the same time, I am checking the squares of these numbers. When the squares are less than 360, I should write a number. What about 7? 7 is not possible because this number is not divisible by 7. What about 8? 8 is possible. 360 is divisible by 8. Okay, and 8 square is 64, less than 360. Continue with this. 9 is possible. 10 is possible. 10 square is 100. 11 is not possible. 12 is possible. 12 square is 144. 13, not possible. 14, not possible, because in 14 I have 7 as the factor, and there is no 7 here, as you see. 14 is not possible. 15, yes, possible. 15 means 3 times 5. 360 is divisible by both 3 and 5. So it's divisible by 15. And I'm checking the square of 15 again. 15 square is 225, less than 360. I should write here 15. What about 16? 16. Is it possible to divide? In 16 there is no 3. No 3. If you check, you will find that 16 does not divide 360. What about 17? Impossible. What about 18? 18 is possible. And the square of 18 is, let's write here, 18 square is 324. Oh, slowly I am coming. 360 when I take the squares of numbers. After 20, 19 is not possible. What about 20? Should I write 20? 20 square is 400, which is greater than 360. So 20 shouldn't be written there. Clean it. I should stop 18 at 18. So let's clean all this and continue with 18 and try to find the remaining numbers, remaining factors. 18 times which number gives you 360? 20. Am I right? Am I right? So why I don't write here 20? Because I will find by multiplying with 18. Okay. 18 is okay. What about 15? 15 times which number gives you 360? Let's try to find. Here, divide with 15. 2 and what? 24. Yes, okay. Clean. Continue with 12. 12 times which number gives you 360? 30. 30. Now let's continue here. Now 18, 15, 12. 60 times which number gives you 300? Sorry, this is 10. Sorry. 10 times which number gives you 360? 10 times 36. 9 times which number? 40. 8 times which number? Divide somewhere. 4 times 8 is 32. 4 and 5. I should write here 45. And clean your division operations. You should be clean. What about 6 times which number? 60. 5 times which number? If you divide 360, which number you will reach? 72. Okay, 72. 4 times which number gives you 360? 90. What about 3? 3 times 120 gives you 360. 2 times 180 gives you 360, and 1 times 360 itself here. I thought up to 18. I wrote here all numbers up to 18. After that, I don't think. I don't need to think to find the remaining factors of 360. I think you understood the way. Now let's apply the way on a smaller number than 360. Let this number be 60. Okay, 60. 1 is always 2 is okay, 3 is okay, 4, 60 is divisible by 4, 5 is okay. At the same time, you should check the squares of numbers, which numbers you are writing here. Very important, their squares should be less than 60. And what about 6 is okay. 7 is not possible. 8 is not possible because 8 square is greater than 60. So I should stop 6 at 6. 6 times which number gives you 60? 10. 5 times 12. 4 times 15. 3 times 20. 2 times 30. And 1 times 60. I wrote here by thinking 1, 2, 3, 4, 5, and 6. After that, I don't need to think on it. Okay? To find 10, 12, 15, 20, 30, and 60. But there is no lack here. There is no lack. I think you understand how you may find all factors of a number. Now let's come to another subject title. Common factors of two numbers. So I should concentrate on two numbers. I should choose two numbers. Common factors, because I will try to find the common factors. Common factors. Now let 12 and 18 be two numbers. Now I will write here the factors of 12 without multiplication method. Okay, let's apply. 1 is possible, 2 is possible, 3 is okay, and stop at 3 because 4 square is greater than 12. 12 times 4, 2 times 6, and 1 times 12. I wrote here all factors of 12. What about 18? 1 is okay, 2 is okay, 3 is okay, 4 is not possible. After 3, stop at 3. Don't write anything. 4 is not possible. Yes, 4 square is less than 18, but 18 is not divisible by 4. 5 is impossible because I should stop at, because 5 square is greater than 18. What about 3? 3 times which number? 6 gives you 18. 6. 2 times 9 and 1 times 18. Now I wrote all factors of 12 and 18. Now let's try to find common factors. Right here. 1. Common factors of 12 and 18. Sorry. 1. 1 is always, as you see, 2 and 3. Did you see? 3 and 6. That's all. That's all. These are all common factors. Now, in this example, 12 and 18 are small numbers. And to find the common factors, we didn't lose a time. We found easily because numbers are small. What about the huge numbers? If I choose, for example, 150 and 360, how can I find their common factors? Now let's try to find on another page one more example. Their common factors. Let the first number be 36 and the second number is 45. Write here all factors of 36. 1, 2, 3, 4, 5 is not possible. 6 is possible. After that, 6 times 6 is 36. 6 written here. 4 times 9. 3 times 12. 2 times 18. 1 times 36. I wrote here all factors of 36 by our method developed before. And what about 45? 1 is okay. 2 is not possible. 3 is okay. 4 is not possible. 5 is okay. And after that, 6 is not possible. 7 is not possible. That 7 square is 49, greater than 45. So stop here. 5 times which number gives you 45? Right here, 9. 3 times 15 and 1 times 45. So now let's write common factors. This example is also was. This example was easy. Common factors. Right here. 1 is always. What about after that? 2, not 3, 4, and 9. As you see, 9. After 9, there is no common factor. So 1, 3, and 9 are common factors. Now I want to show you on this example and on previous example between the common factors, among the common factors, one of them is the greatest. One of them. Here is 9. 9 is the greatest common factor of 36 and 45. What about the first example? Common factors are these, and here 6 is the greatest common factor of 12 and 18. And pay attention please, the remaining factors. Remaining common factors of 12 and 18. The remaining common factors of 12 and 18 are the factors of 6. Am I right? Yes. 1, 2, 3, and 6 are all factors of 6. And 6 is the greatest common factor of 12 and 18. What about the next example? Come to here. As you see, the same result we may reach here on this example. 1 and 3 are the remaining common factors of 36 and 45, and they are also the factors of 9, the factors of greatest common factor of 36 and 45. 1, 3, and 9 at the end. I should say this. 1, 3, and 9 are all factors of 9, which is the greatest common factor of 36 and 45. So, to find the common factors of two numbers, if I may find their greatest common factor, then I may find all common factors of these given numbers, of these two numbers given. All common factors of two numbers are all factors of their greatest common factor. Did you understand? It's very, very beneficial result we reached. So our next title is greatest common factor. To find the greatest common factor, how can I find the greatest common factor of two numbers? Now, as you see, let's work on again the last example. 9 is the greatest common factor of 36 and 45. It means 9 is the greatest divisor of 36 and 45. So to find the greatest common factor, I should find the number which is the greatest divisor of given numbers. Now, to find the greatest common factor, I should find the greatest common divisor of the given numbers. Now, let in this part, on this title, work on a huge numbers. For example, 150 and 360. 150 and 360. Right here, there. Yes. On the last examples, we were writing all factors of these numbers, but now I should find only one factor, which is the greatest common factor. I should find only one common factor, namely the greatest common factor. I don't need to find the others. So how you may find? The greatest common factor is the number which is the greatest number that divides both 150 and 360. So I should find the number or numbers which divides these two numbers in common. So let's write these two numbers again on the same line and sketch a line here. We'll make the division and try to find a number which divides these two numbers. 10, for example, 10. Both numbers are divisible by 10 because their units digits are 0, as you see. If you divide these two numbers with 10, 150 will be 15, 360 will be 36. What about 15 and 36? Can you find a common number divides these two numbers? That's 3. If you divide 15 with 3, you will get 5. If you divide 36, you will get 12. What about 5 and 12? Is there any common divisor for them? No. 5 and 12 can be divisible by only 1. Now, if you multiply these numbers, 10, 3, and 1, of course, 1 is here. 1 is not necessary in multiplication. There is no effect because so 3 times 10 gives you the greatest common factor of these two numbers, 150 and 360. 30 is the greatest one. So if you know the greatest common factor, like here, then you may find all common factors of these two numbers, 150 and 360. So what I mean, 30 is the greatest common factor. So if I find all factors of 30, then I will find all factors of 150 and 360. Now let's start to find all factors of 30, which is the greatest common factor of these two numbers. Right here, 1, 2, 3, 4 is not possible. 5. After 5, stop. 5 squared is 25. 25 is less than 30, so it's possible to write here. But after 5, 6 comes, but 6 squared is 36 greater than 30. So 5 times which number gives you 36? 3 times which number gives you 30? 10. 2 times which number gives you 30? 15. 1 times 30. So I wrote here all factors of 30. It means I found all common factors of 150 and 360. I think you understand. You understood everything. How can you find all factors of two numbers? Firstly, you should find their greatest common factor with this method. After that, you should find all factors of this greatest common factor. Then you will reach all common factors of these two numbers. Okay. Now let's continue with another example. We know I think the way, so we will be faster than the before. Now let the two numbers be 75 and 45. I'll find all factors of common factors of these two numbers. So I should write on a line them, and I should find firstly the greatest common factor of these two numbers. Now can you find a number which divides these two numbers at the same time? 5, for example. If you divide 75 with 5, you will reach 15. And 45 with 5, you will reach 9. What about 9 and 15? 3. If you divide 15 with 3, you will reach 5. If you divide 9 with 3, you will reach 3. What about 5 and 3? 1 only. So 5 times 3 gives you, namely 15. The greatest common factor of 75 and 45. Greatest common factor of 75 and 45 is 15. Knowing the greatest common factor means finding all common factors of 75 and 45. If you find all factors of 15, you will reach the result. Let's write here at the end all factors of 15. 1 is okay, 2 is not possible, 3 is okay, and stop here. 4 is not possible. 3 times which number gives you 15? 5. And 1 times which number gives you 15? 15. Now I wrote here all factors of 15. It means these numbers are also common, all common factors of 75 and 45. That's all. Now this was our last example. Evet, yes, a way to find the common factors of a number has just finished. Now today's lesson is over. I think you understood everything very well. So, hope to see you soon on the next lesson. Hope to see you soon on the next lesson, and bye.